Hey, what is up, you guys? We are recording a video currently, and today's date is the 9th of March, Saturday, and the time is 1:15. Right, so what we're gonna be looking at, it's inverses. I think on this video we've already covered inverses. Okay, so we're just gonna be looking at this question here quickly. Determine the equation of f in the form of f to the exponent -1. Right, so we basically have to find the inverse. That's question 1. Okay, so f of x is equal to 1 over 2 to the exponent 1 over 2x to the 2, and we are told that x is negative or 0. X is negative or 0. So let's get right down to it. Here's the function that we're given, and it's said to be the function f. 1 over 4 x squared, and we're told that x is basically negative. Very important. And then now 6.1, we just need to find the inverse. And remember the inverse? You swap the x with the y and the y with the x. Yeah, because we're reflecting about the line y is equal to x when we're finding the inverse. So here, we've got the y. F of x represents the y, so we're going to put the x in place of it. And this is the y, and we're basically going to, this is the x, we're basically going to put the y in place of the x. And there you have it. And what's left is for us to find what we call, to make the y the formula. So multiply throughout by 4x is equal to y squared. And y is just going to be plus minus the square root of 4x. Okay? And, but remember, they said x is less or equal to 0. Okay, so now this is going to become just what? Let's simplify further. Plus minus 2 square root of x. Okay, so now this is our inverse. Okay, that is our inverse. Now let's look at the next question. Okay, the next question says, on the same set of axes, sketch the graph of f and f inverse. Indicate clearly the intercepts with the axes, as well as another point on the graph of each of f and f inverse. Okay. So now this restriction is going to be very important, when we're drawing our graph. Okay, because we're going to make sure that this, holds as well. All right. So we already know that. So this is 6.2. Now we're asked to, on the same set of axes. In other words, we're not drawing two separate planes. We're going to be using a single plane. So now we know for sure that this is going to be f, right, with a turning point at 0, right? So this is just f. Okay, and when we're drawing our f inverse, we need to be very careful, right? Because they said that the function must be drawn where x is less than 0. So normally you would have something like this. Okay, let me draw it with a red pen. Normally we would have something like this, right, as the inverse. So this actually has branches, right, where, because remember this is plus minus. Okay, so meaning that we would have branches going like this, right, in a case whereby x is actually greater than 0. Okay, greater or equal to 0. But when x is less or equal to 0, oh my goodness, this is starting to make sense. When x is less than or equal to 0, then we'd have a branch like this, right? So this is the actual branch, okay? This is the actual branch when x is less than 0. And if you check, from here going to minus infinity, all the branches, I mean all the x values here are negative. You guys get what I mean? So this is the y-axis and this is the x-axis, okay? So we've plotted the inverse now, okay? So now this is f, the inverse. And you can see that obviously there's an intersection between the f and the inverse, okay? So they said that we must have a point, okay, on each of the graphs, right? So we know that obviously 0 is to 0 is a point that actually belongs to both the graphs. So ladies and gentlemen, that is it. Now let's go right ahead and look at the last question, okay? Is have a function, give a reason for your answer. So we're just gonna do the vertical line test, and you can see the vertical line cuts this twice. So this is not a function, okay? 6.3, the inverse is not a function, simply because the vertical line cuts the graph twice. Cuts the graph twice. Okay? If it cut the graph once, for instance, if you look at f, if you draw any vertical line, it cuts it once. Then f is a function. But f to the negative 1, the inverse, it's not a function. And we're done with that. Question 6. That was quick. Okay. So let's move on to another question. All right, which is on trig. Trigonometry. Let's see what question they're asking us. All right. Okay. So given the sine of 16 degrees equals to p, determine the following without the use of a calculator. Okay. I mean, the rule of thumb is to ensure that, okay, 5.1, we given that the sine of 16 degrees is equal to p, but we know that p is just the same as p over 1. And the definition for the trig ratio sine, it's opposite over hypotenuse, okay? Meaning that the p is the opposite side and the 1 is the hypotenuse. Then we can go right ahead and draw a triangle, all right, with the 16 degrees angle there, 90 degrees angle over there. The opposite side is p and the hypotenuse is 1. Then to find the adjacent side, Pythagoras. So this side, we'll call it x, is equal to that 1 squared minus p squared, which is just square root of 1 minus p squared. All right. So now we know exactly what is substituted over there, 1 minus p squared. Okay, so if one, like, because now we've got the triangle, no matter what question they ask us, we are definitely going to be able to answer. All right, so what's going on here? Now we're looking at 5.1.1, which says determine the following in terms of p, okay, without using calculator. The sine of 196. So obviously there we need to apply a little bit of reduction formula. 96, you can see that 196 is just above 180 but below 270, so it's in the third quadrant. So in the third quadrant we use 180 degrees plus theta, which is going to be 16 degrees, and this just becomes, we know in the third quadrant only 10 is positive, so minus the sine of 16 degrees. But this is the same as minus 1 times sine 16 degrees. So what is sine 16 degrees? Right? It's just p. So minus p. That's our answer. And then by 5.1.2, we are asked to find the cosine of 16 degrees. This is where you have no choice but to come up with that triangle over there. So cosine, it's adjacent over hypotenuse, which is root 1 minus p squared over 1. So root 1 minus p squared over 1, which is just root 1 minus p squared. So I'm referring to the triangle that we drew a couple of minutes ago. And now 5.2 says given that, right, that the cosine of a minus b is cosine of a cosine of b plus the sine of a the sine of b. You guys already know the compound angle identities, isn't it? Right, so look, this is what we have. So but they're saying we must use this to figure out what is sine of a plus b going to be. And we know that the sine of a plus b, according to the cofunction ratio, right, is the same as the cosine of 90 degrees minus a plus b. Okay? Now, we can rearrange a little bit, but obviously we need to make sure that we've got this order here. There's a minus in between two angles. Okay? So what I'm going to do is I'm going to break down the bracket over there so that we can have something similar to that. So this is 90 degrees minus a minus b. Okay? So now we can either group the 90 and the a or the 90 and the b. Either way it's going to work. So the cosine of 90 degrees minus a, we put that in brackets, then minus b. Can you see that now we've got something that looks like that? The first angle and the second angle and a minus in between. So we can copy exactly what we have over there, right? We're just going to say cos of the first angle minus a, the cosine of the second angle, it's minus there, so we put a plus here, the sine of the first angle, okay, minus a, and then the sine of the last angle. Alright, now this just becomes what? Cosine of 90 degrees minus a, that's the sine of a, and then the cosine of b. The sine of 90 minus a is just the cosine of b, right, and sine b. So it's all done, you guys. Okay. So it's the cosine of a, sorry, and then the sine of b. So the problem is done. The order doesn't really matter. You could have started with the cosine of b and then the sine of a and then plus the sine of b and then cosine of a. Order doesn't really matter when multiplication is concerned. Okay, so that's that. And let's move on to another question. So look, almost done here. we're asked to simplify that. I hope you guys can see the expression, right? Even if you don't see it, I'm sure you're going to be able to see it here. So the square root of 1 minus the cosine of 2a squared divided by cosine of minus a cosine of 90 degrees plus a. Okay, yeah, you guys weren't seeing what I was doing all this time. Okay, but anyway, we're asked to simplify this. How do we simplify? Okay, how do we simplify? So what I'm saying is that we can immediately identify the identity for that, right? 1 minus cos squared 2a. It's just the square root. So this is just the square root of sine squared 2a, okay, divided by, remember the cosine is going to absorb the negative there, so this is just the cosine of a. Cofunction ratio, this is just going to be the negative sine of a, because remember the 90 degrees plus a is in the second quadrant, but this trig ratio cos, right, cosine is negative in the second quadrant, so that's why we're putting the negative there. So then this becomes the square root of sine 2a is just sine 2a divided by, we'll put a negative there, cosine of a sine of a. Then we replace that with its identity minus 2. I know it's normally start with the sine, but I'm going to start with a cosine, and it doesn't make any difference, right? I'm just ordering it in such a way that it's easier for me to cancel. So this is just cosine of a sine of a. So you can see that now we've got something that looks identical. The cosine and the cosine, the sine and the sine. And we just get minus 2. How cool is that? Now, another one, 5.4. Now this looks very interesting. 5.4. So we're given that cosine of 2b is equal to 3 over 5. Right, in the first quadrant. So cosine of 2b, cosine of 2b is equal to 3 over 5. Alright, where b is in the first quadrant. Right, first quadrant. Okay, so ideally what we want to do here is we want to expand this using the compound angle identity. Okay, so in other words, we're just going to say ideally you don't want to substitute this with the, there's no need for us to use the compound angle identity, okay, because it's just gonna give us the 3 identities for what we call the 3 identities for cosine. Okay, we might as well just substitute the identity themselves. So, and I'm gonna pick an identity which doesn't have both trig ratios within a single expression. I mean, within a single expression. Why? Because remember, there's cosine squared, right? There's cosine squared b minus sine squared b. There's also 2 cosine squared b minus 1, and then there's 1 minus 2 sine squared b, right? Now I'm gonna pick either this one or that one. This I'm not gonna pick, because I mean, if I pick this one, I won't be able to make, either the cosine of b or the sine of b the subject of the formula, because this is the whole point. I'm trying to get rid of the double angle over there, so that now I'm just left with a simple trig ratio being equal to something on the right hand side. Then in that way I know I'm going to be able to draw the triangle, and if you give me cosine of b, sine of b, the tangent of b, I'm going to be able to find what that is. Do you understand? So that's why I don't want this. Okay, so I'm just going to say fine. I'm going to replace it with 2 cos squared b minus 1 is equal to 3 over 5. And therefore 2 cos squared b is just, so the 1 goes to the other side, becomes what? It becomes positive, so 5 plus 3, that's just 8 over 5. Divided by the 2, cosine of b is just 4 over 5. Alright, now the cosine of b itself becomes plus minus the square root of 4 over 5. But it's been indicated that this angle, the cosine of b, is in the first quadrant. Do you understand? So meaning that the negative one, we are going to, disregard it. So we're just going to be left with positive 2 over square root of 5. Do you understand? The negative one, negative solution, we forget about it. Okay? Then now we're ready to draw the triangle. So happy, you guys. So look. The triangle is going to be like this, like this in the first quadrant, because remember the B is said to be in the first quadrant. Whew. The B is said to be in the first quadrant. So now remember cosine, it's adjacent over hypotenuse. So this is the adjacent side 2. And the hypotenuse, that's just root 5. You know we need to use Pythagoras to find the other side. So it's just going to be the square root of 5 minus 4. Which is what? Square root of 1. So that side is 1. Alright. So we now have the triangle, you guys. And I'm so happy because I know for sure we're going to be able to perform our calculations. Okay, so this here says now we need to go right ahead without the use of a calculator, and we need to find the cosine of b. Okay, and we've already answered that question when we made the cosine of b the side of the formula. So basically the cosine of b is just 2 over square root of 5. So we've answered that question. So we need to move on and find the sine of b, because we've been asked to find the sine of b. Sine of b, we simply go to the triangle itself. Right, here's the triangle. Remember, sine, it's opposite over hypotenuse. So the sine of b is just going to be 1 over the square root of 5. Alright, and lastly we're given we have to find the cosine of b plus 45 degrees. Yes, you guys know that 45 degrees is a special angle. So we're just going to expand this using the compound angle identity. So the cosine of b, the cosine of 45, and minus the sine of b, the sine of 45. Okay, so now we already know what the cosine of b is. Remember we said it's 2 over square root of 5. So 2 over square root of 5 times this, the cosine of 45. If you use the special angle triangles, we know it's just going to be 1 over root 2. Okay, minus the sine of b, we just calculated above, it's 1 over root 5. And times the sine of 45, again it's just 1 over the square root of 2. Okay, and that's pretty much it, you guys. We've got the same denominator here, root 5 and root 2. So this is just going to be 2 times that, it's 2. So it's just going to be 2 minus the 1 times 1, which is 1. So our answer is going to be 1 over the square root of 10. And that is it, you guys. We're done. You know what I mean? We're done. So if you've got any questions, please throw them in the comment section, and we'll try to respond as fast as possible. Don't forget to like and share with people that might be in need of this valuable information. But otherwise, good luck.